Hello students, imagine you're on a ship in the middle of the ocean. You can't see the seabed, but you still need to know how deep it is. How do we do it? By using echoes. Echoes are applied in sound ranging and echo depth sounding, and for this, we use ultrasonic waves, which are sound waves with frequency greater than 20,000 Hz. Their properties make them perfect for scientific and technological applications because they travel long distances without much disturbance. In short, echoes aren't just something you hear in valleys, they're powerful tools for measurement. So why ultrasonic waves? First, they can travel undeviated through very long distances without bending or scattering. Second, they can be confined to a narrow beam, which means we can point them exactly where we want, like a flashlight of sound. And third, they are not easily absorbed by the medium, so they return crisp and clear. That's why ultrasonic echoes are chosen instead of ordinary sound waves. They're precise, reliable, and stable, which is exactly what scientists and engineers need. Let's look at sound ranging. This is the method of finding the distance to a faraway object using echoes. A pulse of ultrasonic sound is sent out, and the time taken for the echo to return is measured. The formula is simple: distance equals velocity multiplied by time divided by 2. The division by 2 is because the wave travels to the object and back. This method helps locate submarines, underwater rocks, and even hidden obstacles. It's like playing detective with sound, sending out a pulse and waiting for it to report back. Next comes echo depth sounding, which is used to measure how deep water is below a ship. An ultrasonic pulse is sent downward. It reflects from the seabed and comes back to the receiver. The depth is calculated using the formula depth equals velocity multiplied by time divided by 2. Since the speed of sound in water is about 1500 meters per second, this method gives quick and accurate results. Ships rely on this to avoid running aground and to map the sea floor. In other words, echoes keep ships safe at sea. Let's solve an example. Suppose the speed of sound in water is 1500 meters per second and the time interval between sending a pulse and receiving the echo is 2 seconds. Using the formula, depth equals velocity multiplied by time divided by 2. Substituting the values, depth equals 1500 multiplied by 2 divided by 2, which gives 1500 meters. So, the seabed lies 1500 meters below the ship. And remember, always divide by 2 because the pulse travels down and back again. So let's recap. Ultrasonic waves are used in echo applications because they travel long distances, can be confined into narrow beams, and are not easily absorbed. Echoes are used in sound ranging to find the distance of objects, and in depth sounding to measure how deep the ocean is. The formula is the same in both cases. Distance equals velocity multiplied by time divided by 2. Applications include submarine detection, seabed mapping, navigation, and even research in marine science. So, the next time you hear the word echo, think beyond valleys. It's a technology that helps us explore the hidden world beneath the waves.